इनके फैक्ट्स को लाइक करना, शेयर करना और सब्सक्राइब करना ना भूलिएगा। अगर कोई आपके मन में सवाल हो तो उसके लिए कमेंट्स कर सकते हैं, आप हमसे पूछ सकते हैं, तो इंशाल्लाह हम उसका जो है जवाब भी देंगे, आपको मुतमईन भी करेंगे, डिटेल भी बताएंगे।
The dust fire and explosive pentagon. The methods to prevent or mitigate the effects of combustible dust explosion and resulting fire. Definitions and terminologies. Combustible dust. A combustible particulate solid that presents a fire or deflagration hazards when suspended in air or some other oxidizing medium over a range of concentrations, regardless of particle shape or size. Smoldering fire. A smoldering fire may occur deep inside a pile of dust or powder. A combination of moisture, catalysts, and/or self-heating can cause smoldering to occur at very low oxidant levels, much lower than possible for a surface fire. Definitions and terminologies. Deflagration. The action of heating a substance until it burns away rapidly, and hot burning material heats the next layer of cold material and ignites it. Most fires found in daily life, from flames to explosions such as from black powder, are deflagrations. Detonation. The bursting or rupture of an enclosure, including a room or building, or a container due to the development of internal pressure from deflagration. Deflagration flame. Confinement detonation. Definitions and terminologies. Detonation. It always occurs after normal combustion is initiated by the spark. If the combustion process moves too fast and the pressure peak occurs too early, the result can be excessive pressure, excessive temperatures, and unstable pressure pulses known as detonation. Detonation is something that occurs near the peak pressure point in the combustion event, after the air-fuel charge has been ignited normally by the spark plugs. Types of combustion. There are three main types of combustion. 1. Rapid combustion. 2. Spontaneous combustion. 3. Explosion. Rapid combustion is a combustion in which a substance burns rapidly and produces the heat and light with the help of external heat. E.g., burning of LPG. Spontaneous combustion is a combustion in which a substance burns spontaneously and produces heat and light without the help of external heat, e.g., burning of coal and phosphorus at room temperature. Explosion is a combustion in which a substance burns suddenly and produces heat, light and sound with the help of heat or pressure, e.g., explosion of crackers on applying heat or pressure. Requirements for a combustible dust hazard. Triangles, squares and pentagons. Fire triangle. The fire triangle is the first set of requirements for a combustible dust hazard to exist. It states that fuel, oxidant, and an ignition source must be present for a fire to occur. Fuel, solvent plus heat, spark plus oxygen, air equals fire. Fuel equals coal dust powder. Heat equals direct heat, open flame, friction, sparks, self-combustion. Oxygen equals oxygen in air. Requirements for a combustible dust hazard. Triangles, squares and pentagons. Flash fire square. The addition of a fourth element in fire triangle, dispersion of the dust, can lead to a flash fire hazard. Sudden, intense fire caused by ignition of a mixture of air and a dispersed flammable substance such as a combustible solid coal. Fuel, coal dust plus heat plus oxygen, air plus dispersion, suspension of dust particles equals fire. Fuel equals coal dust powder. Heat equals direct heat, open flame, friction, sparks, self-combustion. Oxygen equals oxygen in air. Dispersion equals dispersion means the dust particles are suspended in air. Requirements for a combustible dust hazard. Triangles, squares and pentagons. Dust explosion pentagon. The addition of a fourth element in fire triangle, dispersion of the dust, can lead to a flash fire hazard. Sudden, intense fire caused by ignition of a mixture of air and a dispersed flammable substance such as a combustible solid coal. Fuel, coal dust plus heat plus oxygen, air plus dispersion plus confinement. Fuel equals coal dust powder. Heat equals direct heat, open flame, friction, sparks, self-combustion. Oxygen equals oxygen in air. Dispersion equals dispersion means the dust particles are suspended in air. Confinement equals confinement means the dust is in an enclosed or limited space. How is the primary explosion generated? When all of the elements in the dust explosion pentagon are in place, rapid combustion known as deflagration, a rapid burning slower than the speed of sound, can occur. If this event is confined by an enclosure, such as a building, room, vessel or process equipment, the resulting pressure rise can cause an explosion, a rapid burning faster than the speed of sound. Secondary explosion. The combination of the fire elements within an enclosed structure provides the conditions for the flame to quickly spread, creating enough pressure to move any dust from work surfaces. This movement of dust is enough to create chain reactions that result in subsequent or secondary explosions. Possible ignition sources at workplace. Possible ignition sources include open flames and sparks, welding, industrial grinding and cutting, matches, etc. Hot surfaces, dryers, bearings, heaters, etc. Heat from mechanical impacts. Electrical discharges, switch and outlet activation, electrostatic discharges, static electricity. Smoldering or burning dust. Smoking materials, cigarettes, lighters, cigars, etc. How much dust is too much dust? NFPA 654 warns that a dust layer greater than 1/32 of an inch, or the thickness of a typical paper clip, accumulated on surface areas of at least 5% of a room's floor, or above ceiling area presents a significant explosion hazard. Level of lignite coal dust is 15 to 250 gm, M3 sufficient enough to cause explosion. Less than 500 micrometers size is sufficient for ignitable dust size for explosion limit. Oxygen concentration for lignite coal dust is greater than 12% to cause explosion. EPTL site coal dust handling guidelines suggest that coal dust thickness should not be more than 1 mm. It is mandatory to maintain all the times in all area, especially coal handling areas. OSHA time motion study of dust explosion event. Primary deflagration inside process equipment. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. Timing of actual events may vary. OSHA time motion study of dust explosion event. Shock wave caused by primary deflagration. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 1. OSHA time motion study of dust explosion event. Shock waves reflected by surfaces within the building cause accumulated dust to go into suspension. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 1. OSHA time motion study of dust explosion event. Dust clouds thrown in the air by the shock waves. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 1. OSHA time motion study of dust explosion event. Primary deflagration breaks out of the equipment enclosure, creating a source of ignition. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 1. OSHA time motion study of dust explosion event. Secondary deflagration ignited. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 1. OSHA time motion study of dust explosion event. Secondary deflagration is propagated through the dust clouds. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 2. OSHA time motion study of dust explosion event. Secondary deflagration bursts from the building. 02550 100 125 150 175 200 225 250 300 325. Time, MSEC. 2. OSHA Time Motion Study of Dust Explosion Event. Collapsed building with remaining fires. 02550 75 100 125 150 175 200 225 250 300 325. Time, MSEC. 2. Coal dust explosion demonstration. Housekeeping. Hot work protocols. LOTOTO protocols. Severity reduction policies, practices and procedures designed to minimize the spread of fire. Design specifications for storage of flammable materials. Emergency plans. Alarm systems. Portable fire extinguishers. Cleanup policies, practices and procedures designed to return the affected area to an operational level. Removal of debris to an appropriate waste site. Timely maintenance of equipment and facility. 2. Fire prevention and control. Dust control. NFPA 654 suggests. Use cleaning methods that do not generate dust clouds if ignition sources are present. Only use vacuum cleaners approved for dust collection. Provide access to all hidden areas to permit inspection. Inspect for dust residues in open hidden areas, at regular intervals. Clean dust residues at regular intervals. 2. Way forward. Avoid generating coal dust during housekeeping. Use other methods to control coal dust. All efforts must revolve around reduction of coal dust which is under control of workers, ignition source they cannot control but dust cloud they can control by effective housekeeping methods. Do not throw the dust of coal in any equipment, chute of any conveying system, it may cause smoldering later on. Coal dust should be disposed off properly as it is highly hazardous. Dust collection system and dust suppression system should always be in good working condition. Any issue in these systems should be handled on priority. Hot work in coal handling area is highly vulnerable job as one source is added in the system. Ignition. Avoid hot work in coal handling system at the maximum. 2. Way forward. ATEX-20 means only one source is needed for explosion. This site is always having 4 components, means extremely close to explosion all the time. Electrical fittings, fixtures, electrical panels in coal handling system, must be in good healthy condition and electrical panels must be properly closed, sealed. Electrical system can generate spark any time, hence a regular audit of electrical fittings and fixtures in coal handling area must be done. Cable trays and structures which are on elevations and carrying coal dust, must be cleaned through ATEX-20 vacuum cleaners. 2. Thank you.